Okay guys, let's take a look at today's lesson. We're starting a new unit. We're going to be looking at conics for this unit, and this is our first lesson on parabolas. You have already had some experience with parabolas, so some of this is going to be a review, but some of the stuff I'm talking about will be new also. So let's just kind of jump in. So if you recall, we have two types of parabolas, just formatting or orientation. We have parabolas that would either go up or down. Right, those are the most common. I mean, we've looked at those since Algebra 1, right? We know about these parabolas, and this is the formula for that parabola. This is a unit where you will have to memorize formulas. Okay, so maybe you already have this one memorized. This is just for a regular parabola that opens up or down, and K is the Y coordinate of the vertex, and H is the X coordinate of the vertex, just to remind you. Okay, so we also have this orientation where we learned last year about parabolas that would open to the side, right, to the right or to the left, and they have a different equation where the y is squared and the x is not. Okay, but again, the h and k still stand for the vertex. H is the x coordinate of the vertex, k is the y coordinate of the vertex. We have a couple of other formulas we have to memorize. This one, A equals 1 over 4p. That gives us the relationship between A, which is this location right here, and P. P is the distance from the vertex to the focus and the distance from the vertex to the directrix. So that's what P is, a distance. And so this equation gives us a relationship between A and P, so that if we have one, we could find the other and vice versa. Okay? Then the other formula that we need to be aware of is this one right here, absolute value 4p. This is how we find the length of the lattice. It's also called the focal diameter. And so basically what it's talking about is this distance right here, the distance that goes from one side of the parabola to the other through the focus. This distance is called, I usually abbreviate it LR, or focal diameter. So that's what that distance is. One common mistake that students will make, and I try to help you with those, I don't want you to see you make the same mistake, is that once you find this number, let's just say the number is 8. Let's say that in this case, let's say it's 8. Some students think that each side is 8, but that is not the case. The whole distance is 8. Which means that this side would be 4 and that side would be 4. So that's just something we need to be aware of. We don't want to make that mistake. The whole thing, the whole distance of that is 8. All right, what else? So we also have A plays a significant role for us. If A is positive, depending on which orientation we're looking at, it would either open up like this one or right like this one. If A is negative, then it would open down or left. So hopefully we remember that. So that's significant. One thing that I am going to go over with you on each of the conics is the definition, because a lot of the word problems are written with the definition in mind. So we really need to think about what the definition is saying, and that's what I have listed at this very top. So let's kind of think about what it says. It says a parabola is the set of all points equidistant from a fixed point focus and a fixed line directrix. So just to kind of give you a visual picture of what's going on, I don't have the directrix drawn here, but let me just draw one. We're just going to use this as an example. So let's say I'm looking at a point right here. Now please know that this parabola is not drawn to scale. Okay. What this definition tells us is that every single point on the parabola has an equal distance from the directrix to the focus. So those distances would be equal. No matter what point I choose on the parabola, the distance between the directrix and the focus is equal. So see, the directrix plays an important role in the creation of a parabola. We don't, we kind of like, why do we need that line for? Well, I mean, it basically instructs the actual position of each point on the parabola, because it has to be equidistant from the focus and the directrix. Does that make sense? So sometimes you may have a word problem that uses that concept. Maybe they'll give you some distances and you'd have to figure something out. You know, it's certainly possible. So I wanted to go over that. So I think we have everything on here. Any questions so far? Okay, we just have a couple of examples on the next slide. If we just move over there. Now, I had to change. I changed this problem probably about 9:30 last night. I wanted a more interesting problem for us. The one I had on there was boring. So this one is way more interesting for us. So I changed it. If you printed your notes after 9:30, you probably have this problem. If you didn't, you probably don't. So if you would just fix it for me. Sorry. I thought, I need to fix it real quick. So we have really two focuses today. One focus is to graph a parabola and find all the parts of a parabola. And the other focus is to write the equation of a parabola from, information that we're given. So those are our two focuses. So we're going to start with graphing first. I'm going to remind you about something fun, which is completing the square. All right, so completing the square. So completing the square actually is a really big deal. Maybe you remember it from last year, maybe you don't. We complete the square in calculus. It's a concept that you're going to need to know. So it's no matter which calculus you take, you're going to be completing the square at some point. So it's pretty important. So let's remind ourselves how to do that. So I prefer working with a positive y squared or x squared, right? I would rather complete the square with a positive squared variable than a negative squared variable. So I'm going to move the y squared to the other side. Okay, so we're going to move the y squared over, and I'm going to move the 31 over, and I'm going to talk about that. Okay. So let's move the 31 over, and then let's move the y squared over. Now let's talk about why I moved the 31 over. This is something that students kind of are hesitant to do. I mean, even in calculus, they're kind of hesitant to do that. So I don't want to have a constant on the side where I'm completing the square. So let me give you an alternate example so I'll explain why. So we're going to hold it right there, and I just want you to look at an alternate example. We're going to work it also. So let's say that I have, let's say x equals y squared plus 2y squared plus 8y plus 31. Okay, let's just say something like that. Now let's dig back into your memory of completing the square. Can I complete the square of something that has a leading coefficient other than 1? No, I can't. I have to fix it. So many times students would really want to divide 2 out of all of these numbers. No, that's a bad idea. Don't do that. This number really shouldn't be over there with it. We should have moved it over to the other side. Okay, so let's do that. I mean, let's move it over to the other side. So x minus 31 equals 2y squared plus 8y. Okay, that's what should have happened. So we would divide 2. We're going to divide 2 out of here. Okay, so I'm going to pause on this equation, and we're going to move back to here. I'm going to finish our original one and then go back to this, because I want us to understand that this is a fairly simple completing the square. I don't have anything to divide out. I mean, this is the example that I have, but I want you to understand there are going to be examples where it's not this simple. You're going to have to divide out this leading coefficient. So I want to address that with you. So let's finish this one. So let's remind ourselves. So let's see, we half b, right? We take half of b, half of 8 is 4, and then we square it, and then we add it to both sides. So 4 squared is 16 plus 16 plus 16. Now the fact that I added it to both sides is significant. If you recall way back from Algebra 1, to keep the equation balanced, whatever we do to one side, we have to do the other, right? We need to keep it balanced. So if I added 16 over here, I add 16 over there. So now that I have completed the square, this is a perfect square, and I can factor it to be y plus 4 squared. And then, let's see, negative 31 plus 16 is a 15. Actually, negative 15. And I do want to talk about the factoring. Maybe you will already know this, and that's great if you do. These perfect squares always factor the same way. There should never be any question. They always factor the same way. Whatever the sign of b is the sign of your factor. Half of b is always this number. Always. It always factors the exact same way. You shouldn't have to try to factor this in your head. It's just a pattern. Because of what we did, that's the way it factors. Alright, so let's finish this little guy up. So x can't have a coefficient either. If you recall our x minus h equals a times. Okay, that's what we're going for, right? That's our equation that we're going for. That's one we would memorize if we haven't already. So notice how x doesn't have anything in front of it, so I need to pull out a 3. So some students were leaving it like this and wondering why they were getting, the p wrong. Well, I can't have the 3 over there, right? I've got to divide it. So a is with the squared variable. A is not over here. So I have to move it. So my final standard equation will be x minus 5 equals 1/3 times y plus 4 squared. Okay, so we are always matching this. If you have this memorized, it'll be pretty straightforward. If you don't have it memorized, it's going to be a little hard. So let's go back to the other example problem where we're doing some crazy stuff over there. Just so we're going to encounter other problems. So I've got to factor a 2 out of here before I can complete the square, right? So I would do 2 times y squared plus 8 divided by 2 is 4. I'm going to leave some room. Okay, so we have the x minus 31 over here. All right, so we do our procedure. We half b, so half of 4 is 2. 2 squared is 4, so I add 4, but pause. Did I really just add 4 over there? I didn't, did I? Didn't I add 8? Right? I added 8. Yes, we have to really pay attention to that, because that's another common mistake, is that we just are so used to adding 4, we just jump and add 4, but that's not really what we did. We added 8 over here. So we have to add 8 over here. And then this would be whatever, negative 31 plus 8. What is that? Negative 27? No, what is that? 23. Right? There we go. Okay, so that would be our equation. Okay? Yes, I can do calculus. No, I can't do adding and subtracting in my head. It's okay. It's all right. We all have our strengths and weaknesses, right? All right, so let's continue on with our regular problem, and let's, what I like to do, now there's a lot of formulas you could memorize, but what I like to do is just to build it as I graph it. So I'm going to read, this is a beautiful form because it has the vertex embedded in it, so I'm just going to write the vertex from this form. It's going to be 5, negative 4. Right, it's just embedded. So I'm going to go over here, I'm going to plot the vertex. So 5, negative 4. Okay. In order to find pretty much everything else, I've got to have p. I need to know what p is. Remember, it's that little formula, a equals 1 over 4p. So I need to find it. So I have a is 1/3. Now I want you to think about this. If I had left this over here, what would I think a was? I would think it would be a 3, right? I would think it would be 3. And it's not. It's 1/3. So it would really mess up everything else. So I just want to make sure it has to be in this form, or you're going to take some wrong readings off of it. All right, so a, which is what, 1/3 equals 1 over 4p. Now some of you can look at that and say, oh, I know what p is right now. I don't have to do anything else. And that's great. Others of us need to cross multiply and solve for p. So we would do 3 equals 4p. So p is going to be 3/4. Okay. So p is 3/4. All right, that's a distance. Now it is significant that it's positive. I'm going to be talking about the sign of P, because I think we kind of overlook that, and it really is significant. So what that's P, we think, oh, that's just a distance. We don't care if it's positive or negative. Really, whether it's positive or negative indicates the opening of the parabola. That's what it does. If P is positive, it's going to open to the right or up. And if P is negative, it's going to open to the left or down. It really is like kind of like A. You know, it has the same tendency as A, because they're related to each other, right? This is the relationship A equals 1/4P, the relationship between A and P. That's why we need to understand that, so we know, how to find A or P. So I'm looking at a distance that's positive. So let's see, what are we doing? We are opening right, aren't we? It's a y squared. It's A is positive. We're opening right. So I'm going to go 3/4 of a space this way, and that's my focus. And I'm going to go ahead and write the coordinates of my focus down. So my focus is 5 3/4. I'm okay if you use a mixed number there. I'm not really a big fan of mixed numbers, but in this case I think it's nice. It's easy. 5 3/4. And my y coordinate is a -1. Excuse me, -4. Okay, so there's my focus. My directrix is equidistant on the other side of the vertex, right? So it's 3/4 on the other 3/4 spaces on the other side. So there's my directrix. It's an x equal equation, right? It's an x equal equation. X equals, and that would be what, 4 1/4. Okay. Now, axis of symmetry. Let me draw it first before I talk about axis of symmetry, because I think it was a little weird to talk about it yet. All right, so let's find the length of the lattice. So that's our formula, absolute value 4P. Now, do we see why absolute value is important? Right, because P could be positive or negative, depending on the opening of the parabola, and the focal diameter is just a segment. So we would do, let's see, so 4 times, what do we have, 3/4? And so it's 3. Okay, so the total distance is 3. Total distance is 3. So that means I go to the focus, which is right here, and I go 1.5 spaces on either side. So 1.5, 1.5, and now I can actually draw the parabola more accurately. So it's going to come this way and that way. Now, in my work, I actually draw the focal diameter in, or the lattice. I actually draw it in. You don't have to. You do have to plot the points properly, but you don't have to draw this line if you don't want to. I am. All right, so now let's talk about axis of symmetry. Just to recall from our symmetry work, it's the line that cuts it exactly in half. So if we fold it over itself, it would match perfectly, right? That's a line of symmetry. The line of symmetry on this parabola would go straight through the middle, right? Straight through the vertex. So this would be at my axis of symmetry right here. And this would be an y equal equation, wouldn't it? It's going to go through the y-axis. So it's going to be y equals, what, -4. Okay. Our domain starts right here. What is that, 5? So it goes from 5 to infinity. And our range is -∞ to infinity. Okay, how is that graphing? Are we okay? Is everybody okay? Okay. This next problem is really, I think, is very interesting. Let's read it. So we're going to find the standard form of the equation of the parabola. They give us the focus. They tell us it opens left, and they tell us a random point on the parabola. Great. How are we going to do anything with that? All right, we don't know anything about the vertex. We don't know anything about the distance P. I mean, this is a quite unusual kind of problem, which of course I have some on the daily work. So let's think about this. Well, when we don't know what to do, I would suggest you just write the standard form up there, just a generic standard form. We know it's going to open left, so it's going to be one of those x equal equations, right? It's going to be x minus h equals a times y minus k squared. Okay, so we're just going to write that up there, try to piece together what in the world to do here. And why don't we just go ahead, let's the focus is at 2, 1. I'm just going to draw a little picture. So the focus is at 2, 1. It's right here. And it's opening left. Let me just move this a little bit over. Okay. So here's my focus. And I know it's opening left. So it's going to look something like this. I mean, I have no idea where it is, but it's going to look something like that, right, if it opens left. Okay. So we got some pictures going on. Let's think. So I do know the y coordinate of my vertex, don't I? I know that. I just don't know the x coordinate. So that's going to be helpful. So my vertex, I know, is h, which I don't know what that is, 1. Right? I know the y coordinate is 1. Okay, so we know that. We know we don't know how far on either side. We do, though. So this is a random point. This is not necessarily. It does contain 2, 5, but I don't want to go there because this is, you're not going to get them like this with the same x or the same value, the same x value normally. So we're going to go with it without looking at the lattice. Okay, so what we're going to do is we're going to focus on P. When you have an equation like this that has this a random point, this one actually isn't so random, but normally it's just a random point, then we need to start talking about P. So let's start talking about our x coordinate. Okay. So this distance, though we don't know what it is P. Right? We don't know what it is, but we know it's P. So I could say that h would equal, okay, that's my x coordinate. Well, let's think about this for a second. It's referencing the focus at 2, right? And since I'm opening to the left, what is the sign of my P going to be? Negative. So I want you to think logistically. If I knew what P was and P was positive, wouldn't I just say 2 plus P? Are you with me? Wouldn't that give me this location? 2 plus P would give me this location, whatever that happens to be. Well, P is negative, so I can't say 2 plus P. I would have to say 2 minus P. Right, minus a minus, because whatever P is, it's negative because we're opening left. So h is going to equal 2 minus P. Now I'm going to pause there for a second because that caused some confusion earlier. So I want you to think about that for a second. So the x coordinate of my vertex, I'm going to start with the x coordinate of my focus, and I'm going to subtract this distance, or subtract P, because P is negative. P is negative because we're going this way. Okay? Are we okay? You're still looking at me like you have lost your mind. I have no idea what you're talking about. Okay, so let's put a number with it. Let's pretend. Okay? Let's pretend that P is negative 2. Let's just pretend. Because it's got to be negative. We understand it's got to be negative. We're opening left. Okay, let's pretend P is negative 2. So if P were negative 2, what would be this x coordinate right here? 4. 4, right? Would it be 4? You with me? Okay, that's just with numbers. Right? It would be 4 because I would do 2 minus a minus 2. 2 minus P. This right here. P is negative. And of course that's a mess. 2 minus a minus 2. Come on. Seriously. Okay. Where am I? There we go. It just took this arrow instead of that arrow. Whichever arrow, doesn't matter. Great. We got it back. It's like, what? That's craziness. That was just a little bit. And I was just trying to, instead of erasing this mess, I'm just going to write 2 minus a minus 2. That's what we're doing out here, right? And so I have 2 minus p, which is negative. Now, are we all clear how we get h? All right, so we also know a, there's a formula for a in relation to p, right? Don't we, isn't there a formula? A equals 1 over 4p. So I know h is 2 minus p, and I know a equals 1 over 4p. I'm going to take that information, I'm going to put it into this equation, my standard equation. So x minus, so h is 2 minus p, equals a is 1 over 4p times y minus k squared. So I'm just going to pause here for a second. So I'm just making sure that I have p's in place of the things that I can. All right. So don't I know what k is? It's 1, right? Isn't k 1? And what about, aren't I given just random points somewhere? Right? What can I do with the random point? Plug it in for x and y, right? Let's plug it in for x and y. So let's do that. Let's do that all at once. I'm gonna take x and y, and I'm gonna put this point in its place. And k we already agreed was 1, so I'm gonna plug those in. So I have x, which is 2 minus p equals 1 over 4p times y is 5, k is 1 squared. We okay? So what's our job going to be now? Solve for p. We need to solve for p. So when we solve for p, it's basically going to open the door and let us find anything we want, right? Once we get p, then we can get our a, we can get our h. We're set to go. So we just need to find that. So let's work on that. So 2 minus 2, that's gone. So a minus minus gives me a plus p equals 1 over 4p times, what's 16? So we need to get the p's together. I would multiply both sides by the reciprocal, 1 over 4p, I'd multiply by 4p on both sides. So that would give me 4p squared equals 16. So p squared is 4, so p is a plus or minus 2. And we know it's opening left, so we know which one of those p's to use, right? Now, I'm just going to say it's not always going to be like a plus minus 3 or plus minus 2. There's the one that I gave you on your daily work has 2 different numbers. How are we going to know which one to use? We're going to know by which way it opens, right? That's how we're going to know whether to use the positive p or the negative p. Okay, we're all clear on that? All right, so now that I know what p is, and we're opening left, so p is actually going to be negative 2, right, because we're opening left. I'm going to go ahead and put that in for a and h, figure that out. So we put, so I have a equals 1 over 4 times negative 2. So a is going to be negative 1/8, right? And then I'm going to put this in here. So h equals 2 minus a minus 2. So h is going to be 4. So we have x, and h is 4. So we have x minus 4 equals negative 1/8 times y minus 1 squared. See how that one was way more interesting? I don't know if you looked at the one I had up there, but that's way more interesting. Are we okay with that? Okay. As okay as we're going to be right now. I'm sure we're going to be masters at it soon, but okay.